Take it away.
All right. Hi, everyone. I'm Linnea. I am a junior in the biology program, but today I'm here to talk to you about math. We're going to go through some like the big broad strokes of algebra. We're going to just get back in there and kind of review. This is not by any means like an in-depth review. I tried to kind of just give the big ideas so that you can kind of be reminded of perhaps some of the tools that are in your toolbox. And if you need to go back in and do some more detail work, that is kind of the goal rather than to remind you of all the algebra that exists in the world. So without further ado, I will pop my little slideshow up. Can everyone see that okay? Great. Okay. We are going to kind of start simple and then we'll get a little more complex as we go. Once again, not at all like comprehensive. I just kind of tried to get the big ideas of what I found to be helpful when I was taking calculus specifically. But just these are kind of, I think, the big topics that kind of encapsulate everything else. So the big idea of algebra, right, is that we're replacing numbers with either symbols or variables, and we usually solve for those variables, right? And we can do that a number of ways. We can isolate the variable to one side, we can substitute, we can manipulate our expression through arithmetic. And that's basically what algebra is. The trick is just remembering all of those rules, right? And perhaps one of our simplest rules is, hold on, while I figure out how to advance the slides. Hold on, there we go, is our good friend order of operations. This one, it's really, you know, the basic rule that we've been practicing since we, knew what math was. And of course, we proceed to evaluate an expression in terms of parentheses, exponents, and then we move on to our division and multiplication. And then we go on to our addition and subtraction. Pretty straightforward, but it's something that I think gets overlooked because it's so simple that sometimes we just forget. But when in doubt, pen miss, as we call it in the United States. Second is our fractions. This isn't really algebra, but I remember really having to kind of think about fractions when I went back in to do some harder math. Once again, because I think that it's not something that you will automatically think of when you think, oh, I'm doing algebra, I better practice my algebra. But some people, I think, forget about the fraction part, which is also important. So just the basic strokes, right? If you're adding two fractions or subtracting, you want a same denominator. In this case, we have the same denominator, our variable c, and so we can just combine accordingly whatever our tops are, and we'll combine with the same denominator. Same thing here is that we want to get the same denominator, but in this case, we start with different denominators in both our addition and subtraction. So you want to somehow create similar denominators, right? And so we want to multiply the other fraction by the denominator, and then you'll come up with the same denominator, and then you can just combine because now we have the same denominator. Once again, really straightforward, but I think something that people can forget. Multiplication and division of fractions. This is much simpler. If you have multiplication, you can simply multiply across. And division is essentially multiplication, but you flip and take the reciprocal of your second fraction, and then you can just do your multiplication across. So that's kind of our crash course in fractions. And now you can take those rules and apply it to something like this that looks kind of crazy and complicated, but it's really just an application of those rules that we went over. And so we won't, I know we're trying to keep this short, but take a moment to just kind of look through this and think, hey, where can I apply those rules that we just talked about and those principles? And you might see that, oh, you kind of start eliminating out some of the tricky bits of it from first glance, and it would resolve itself pretty easily, actually. Okay, we're moving on to linear equations. Linear equations are good friend y equals mx plus b. The formula of a linear line, either going up or going down. This is also where you would probably see inequalities pop up. But similar idea, y equals mx plus b, where we have our slope is m in this case, b is usually the intercept, and we're just solving lines. Something else that you might need when you're talking about linear equations is just your point slope formula, like finding the slope is right. You take the y and x of one and you subtract it from the y and x of another point on the line. I didn't have a good example there, but that's something else that you might come up with linear equations. And so the most basic form probably that we've seen in algebra is just solving for, if you have the slope and you have the intercept, you can solve for points on the line, assuming that you have one of these other variables. And so you might see something like this, if like in its most basic form, right? If you're trying to solve for x, of course, one of the rules in algebra is anything you do to one side of the equal sign, you also have to do to the other. And you also want to isolate your variables to solve for them. So in this case, we want to combine all of our like terms. So in this case, our 2x and our 5x are like terms because they both contain x's. We want to contain our digits on one side. And then we'd also need a division in this case because there'd be a leading factor coefficient, that's the right word. And then we could solve for x in this case. Same idea here, you just have an inequality sign instead of an equal sign. And this one is actually kind of more like a piecewise function, which is another thing that you may or may not need to review depending on your course of action. So yeah, that's kind of one level. The next level is we start to add more terms. We start to add maybe some exponents. And so we move on to our friends, or maybe not friends, the quadratics. A quadratic usually comes in this form, ax squared plus bx equals c, plus c equals 0, sorry. But you can also see it in this vertex form that I have on the right here. That's a little less uncommon, but I did have to work with it a little bit in my calculus class, so I thought I'd just throw it up there. I won't go into the details of working this out. Once again, this is kind of more of a reminder because we don't have all the time in the world. And some common things that you will do with quadratics are you might have to factor them, and that's finding, it's kind of breaking them up into littler pieces. So in this case, we're taking this, I guess expanded form, and we're making it into the factored form where you have one factor, two factor, and then to solve for x in this case, you could set each of these factors to 0 and solve for x, and you would get your two intercepts. The opposite of like going from an factoring is expanding or using FOIL, which stands for first, outside, inside, and last. And if you do the multiplication of the first terms, the outside terms, the inside terms, and the last terms, you come up with the expanded form. So those are the ways that you can go in between those two. Another thing with quadratics is, of course, the quadratic formula. If you can't, solve a quadratic through either factoring or some other things that I've thrown up here by like solving by completing the square or taking the square root, you might have to resolve to the quadratic formula, and this is a reminder of what that looks like. Yeah, I think that's all I have to say on this topic. And so here are just some kind of practice ideas that we may or may not get to, we'll see. But this is what you might see out in the wild. Then we move on from quadratics and we add more variables, we add more terms, and we get to polynomials. In this case, I, for some reason, didn't go into very big polynomials, but you could theoretically have any number of terms, right? I just ended up to stop at a cubic polynomial here. But so with polynomials, you can do a couple of things that are pretty common. You can add and subtract them. And this is just combining like terms again. It just looks a little different. You can also multiply them out and make sure that you're multiplying and distributing every single term to each term in your second polynomial, right? So that's a little tricky, keeping track of which ones that you've done. But you're basically distributing each term into the other polynomial, right? And then technically you can divide a polynomial with another polynomial, Those using long division, but that's another thing. I think I only had to do it once and it's really hard, but that also exists if for some reason you have to resort to that. But if you don't have to do the long division, this is actually called a rational expression. It's not a polynomial if you have an x in the denominator, you create a rational expression. So this is no longer a polynomial, even though it is composed of two polynomials. And yeah, that's basically it. Then we move on to functions. This is once again really quick because there's a lot to cover. Functions are equations where you have one input and one output. You might remember the vertical line test if you're looking at a graph. I didn't include pictures of graphs here because that was a lot of copy and pasting and I didn't have time for that. But you can imagine, right? You can picture maybe some graphs in your head and you can imagine taking that vertical line test, right? And you're just taking, whether it's a pencil, your finger, I've heard and you're dragging it across. And as long as you're only crossing whatever your graph is at one point, whenever you're hitting it with the vertical line, you're okay, that's a function. So like a circle would not be a function because you're hitting, 2 points potentially on that graph, right? So that's not a function. But since linear line is a great example, right? Anytime that this has a crossing a vertical line, you only have 1 point, so it's a function. This is a really simple example of a function. But if anytime you're plugging in one value, for example, if I plug in a 2 to my function, it's going to spit out a 4, and that can be confirmed by the graph here. 2, and we come up to here to 4. So this is a very basic function, but all functions will operate this way in that you're putting in an input and you're getting out some kind of output. It just could look more complicated. Okay, now we're moving on to exponents. This is where I'm going to spend a little bit more time because I think these can be a little bit more confusing for people. But these are just a set of rules, right? A set of rules for, go back. A set of rules for manipulating terms with these exponents in them, right? And so we have the multiplication property, which is if you have two numbers with the same base but different exponents, you can add the exponents together and put them over that same base. So in this case, they're doing it with 2's. Twos are in this base. They're the same, obviously, and so you can add those to get an 8. Similarly, if you have division, you can subtract those two exponents from each other like they're doing over here. If you're raising an exponent to an exponent, or the same thing would be saying, you're taking an exponented term to an exponent. I'm not sure if that made sense, but if you're raising an exponent to an exponent, you multiply those two terms together, and you can combine them like so. Or you could go backwards, right? If you wanted to for some reason separate it out, so you maybe could cancel it with something else. Who knows what you're trying to do? You can, if you have two terms within parentheses that are both being raised to an exponent, you can distribute that exponent into the terms, but only if you have multiplication in here. If you have addition in there, you can't just distribute in your exponent. You have to do the actual full multiplication of that. In that case, it'd probably be a polynomial. So make sure that you have a multiplication in here before you go in and distribute your exponent on the outside. Similar idea, if you have division, you can distribute it inside. Once again, make sure that you have either multiplied terms together. You can't have addition or subtraction in there. Oh yeah, one more is the reciprocal rule. If you have a number raised to a negative exponent, you're creating a reciprocal. It's just that number under a 1. And oh yeah, bonus rules that sometimes people forget is that if you're raising any number to a 0, you get a 1. And if you raise any number to, sorry, did I say that right? If you raise a number to a 0, it equals 1. If you raise any number to 1, you get that number itself again. Because remember, exponents are just repeated multiplication. So it makes sense on that front. Okay, I'm gonna keep plowing ahead and we can do questions and stuff after. So here's some examples. Maybe take a few seconds to see if you can see how these rules that we just talked about might be applied. In this first one, I'm seeing a division bar, which is kind of making me think subtraction. So maybe subtraction could be involved here. Here I'm seeing the multiplication sign. So those are probably going to be added. Here we see our exponent to an exponent. So that's probably going to be distributed inside, and double checking to make sure that we have multiplication there. We do, so that's okay. And these will be kind of a repeated of this one. They're just formatted a little differently. We can add these together since these all have the same base. All right. Roots are just fancy exponents. That's all they are. I know they can sometimes look confusing if you're in the depths of an equation and you come across this thing and you're like, well, what can I do with that? Or it's written like this and you're like, well, what does that mean? Roots are just fancy exponents. So you can rewrite a exponent as a root or root as an exponent. The top number comes down and attaches to the, we'll call it a base, maybe your variable in this case. And the bottom term in that fraction becomes the degree that the root is, the degree of the root. So in this case, it's 3. So this is a cube root. And it can be written either with the top number inside or outside. These are equivalent statements. You could put it in your calculator and it would spit out the same answer. All right. Double checking notes. I think I'm good. Okay. Yeah, so for example, this one kind of looks a little, it looks like a lot. There's a lot of exponents there. There's 2 roots there. How could we eliminate the denominator and rewrite using the exponents? I'll let you take a minute to think about that, but think about, it might help you to think that roots are just fancy exponents. And so, oh no, where'd it go? And so that might help you solve this problem if you were to attempt it. All right, moving on to our last topic are logarithms. Logarithms are another way to write exponents, essentially. They're just, people think of them kind of as different things, but they're really the same thing. We're just seeing how many times, what exponent do we need to get to some number, right? And it's just how many times do we need to multiply our base to get to this number, and it's x many times. So they're really connected, even though some people don't see that immediately or forget since it was taught to them last. There are also some rules that we can apply to our logarithms. They can be rewritten a couple different ways depending on what you are given. They're kind of similar to the exponent rules. You have a product rule where you can separate out or combine logarithms using addition, or you can combine them again into one log and multiply the contents of your log together inside one log. Similar with a quotient rule, right? You can either separate them out into separate logs that are related by subtraction, or you can combine them into one log with division. The power rule allows you to move the exponent within the logarithm out to the front of the logarithm. This one, if you're going into calculus or have taken calculus, you'll know that this is a lifesaver. So that is a very helpful one that I would definitely encourage you to remember. There's also the change of base rule. I don't remember using that one a lot really ever, but it exists. So just, maybe try to keep it in mind if you can. There's also similar rules to what we saw with our exponents, that if you plug in a 1 to a logarithm, you get a 0. If you match your bases in both on the base term and within your logarithm, you get a 1. And a reciprocal can also be written with a negative. It's just out in front of the log in this case. If you have contents of a log raised to a power and your base is the same as the base and the contents, if that makes sense, those cancel out and you get whatever your exponent is. To quote unquote get rid of a log in an equation, you can raise your log to whatever the base power of the log is, and those will cancel out and you will be left with the contents of your log. So it's kind of a lot, but these are really good rules to keep in mind. And natural logarithms, same thing, is just has a specific base that mathematicians have decided to give a different name because I guess they use it so much. It's natural logs are logarithms with Euler's number in the base. And they're just written like ln, and your same log rules exactly apply. So you can do your product rule, you can do the power rule. If you have, right, because you can imagine like a little e down here technically, so those cancel out and make a 1. Natural log of 1 is 0, and you can also do a similar reciprocal thing. So that is very handy. It's just saying how many times do we need to use e to get to our desired number. Same thing, same exact thing. And here's kind of some examples of maybe what you might see in the wild. I'm seeing here that we have 2 logs connected by addition, so we might want to combine those 2 contents into 1 log. Who knows? And this one, it looks like our x is up in the exponent. So how do we get that out of there and solve for it? That's we could use our log rules for that. And that is my crash course in the big topics of algebra, at least the ones that I think are important. Some tips that I would have to anyone just maybe not feeling comfortable with their algebra or going up into higher math and not feeling as comfortable with your algebra. Something that I encourage both myself to practice and when giving advice to other people, if you're stuck on a problem, try to think if it's the advanced math that you're learning at the moment, or if it's just the algebra that's tripping you up. Sometimes that can be a very important distinction to make and will help you solve your problem without being confused by, oh, this is higher math, this is all new, I don't understand what's going on. Take a moment to think, or is it just some algebra rule that I'm forgetting? That might help solve your problem. Another thing is get to know your calculator. I wish someone had told me this earlier, I wish someone had told me this earlier in my math career. But this machine that we're given here, it's got so many cool tips, tricks, buttons. Know how you can maybe store a variable, know where all your buttons are. It will speed you up, can make you more efficient. It can maybe help you out of a tight situation. Who knows? But get to know your calculator. It's your best friend. Be strict with your notation. It really can help other people read your work, whether that be your professor for grading purposes, or if you need to get help and you need someone else to look at your work, it can help speed up the process if you are good about your notation. And it will help yourself too if you need to ever look back at your notes and try to figure out what was going on. For example, lining up equal signs, making sure everything is legible, putting negative numbers inside parentheses. That was a habit that my calculus teacher got me into, and it made reading negatives a lot easier. Another big rule in algebra is beware of dividing by 0 or putting negative numbers where they don't belong, such as in logarithms. You can't do that. That gives you an undefined value. Utilize resources such as Khan Academy is one of my favorites, YouTube channels, and there's so many other different places that you can go online to get resources, or you can contact people in our that you know, through Discord or in person, or come to a study session. Those are also great ways to get help. And last, I would just say practice. If you have something that you aren't feeling solid on, spend a little while and practice it. Go find some practice problems and make sure that you got it down, because it might save you in a test situation. Or if you're struggling with a problem, like I set up here, it could just be the algebra. Who knows? So yeah, that is my crash course in algebra. So yeah, I guess I should ask if I had any questions.